along with our information about experimental method. Remember, we're working on data structures and the different types. We have experimental and non-experimental. The controls are things that the researcher has to exercise control over to ensure that in the study or the research situation, the other extraneous variables do not influence the relationship being examined. So for instance, if you were looking at a study that involved the number of cookies someone ate and whether or not they gained or lost weight, and then, okay, you monitor their cookies, but you don't also check for ice cream and pasta and cakes and all the other goodies that are out there, well, they could just be eating those, and that could be causing the weight to gain, even though it looks like they're not eating as many cookies. So those are things that you would have to control. Not the actual item you're looking to correlate itself, but things that could also affect the result. In the experimental method, the manipulated variable is called the blank, and the observed variable is called the blank. The manipulated one is called the independent variable. It's the one that is changing, and then what changes based on that. This is the one that you're manipulating to go up and down. But then because of that, something depends on that to get its change. So that's called the dependent variable, okay? So the manipulated one is the independent one. And then the thing that changes based on the independent one, that's called the dependent one. All right, so that's for experimental data. Now we have non-experimental methods. Other types of research studies, known as non-experimental or quasi-experimental, that means kind of experimental, are similar to experiments because they also compare groups of scores. But these studies do not use a manipulated variable to differentiate the groups. Instead, the variable that differentiates the groups is usually a pre-existing participant variable, such as male-female, or a time thing such as before or after. Okay, so these studies do not use manipulated variables to differentiate between the groups. Instead, they differentiate between the groups as usually a pre-existing participant variable. Okay, because these studies do not use manipulation and control of true experiments, they cannot ever demonstrate cause and effect relationships. As a result, they are similar to correlational research because they simply demonstrate and describe relationships. As one goes up, the other tends to go up or down. Okay, so it's kind of like correlational research in an experimental form, and that's why we could use the term, because it's kind of like a quasi. Okay, so let's look at this chart about non-experimental methods. Variable 1, the subject gender, the quasi-independent variable, not manipulated but used to create two groups, boys and girls. Okay, and then the verbal test scores that are measured in each of the two groups. So this is non-experimental because the independent variable or quasi-independent variable is boys and girls. It's not something that can be manipulated. Next, time. It's the quasi-independent variable. This is the bottom set here on the below section right over here, okay? The quasi-independent variable, it's not manipulated. You're not manipulating time, but you're used to create two groups of scores. In other words, time in this sense is not counted time. It's, well, before, say, physical therapy began and after physical therapy began, or before psychotherapy began and after psychotherapy began. And then the depression scores, which is the dependent variable. The depression, it's based on whether it's before or after therapy. So that becomes definitely the dependent variable. It depends on the therapy, okay? Here are some concept questions to reinforce what we got going on. What two elements are necessary for a research study to be an experiment? For a research study to be an experiment, what two things are necessary? Pause the video, answer. Manipulations and control are necessary. You need to control, when it becomes an experiment, you need to control those other factors, the extraneous ones, and you need to be able to manipulate the independent variable and see what happens to the dependent one. Researchers have observed that high school students who watched educational television programs as young children tend to have higher grades than their peers who did not watch educational television. Is this experimental or is it non-experimental? Well, it's going to be non-experimental because there's no control over that independent variable and there's no manipulation. Okay? It's just the categories would be exposed to television when young, not exposed to television when young. All right. All right. So let's talk about concept questions now. For an experiment comparing two methods for teaching social skill training to autistic children, the independent variable is what? And the dependent variable is. So the first choice, like in A, teaching methods would be independent and autistic would be dependent. Okay? So look through, see what choice you like the most. Of course, pause the videotape while you work it over. Okay, the correct answer is that the teaching methods are the independent variable because you're able to manipulate those, and the social skills are the things that depend on what it is that we're using as the independent variable, the thing we are manipulating. Okay, next up. For a research study comparing attitude scores for males and females, participant gender is an example of what kind of variable? Well, it's going to be quasi-independent. It's quasi-independent because, again, it's not something that measures across. It's male-female gender related. Okay? Just a quick reminder of that. If you remember this particular chart, when we talked about the variable number 1, subject gender was a quasi-independent variable. Okay? All right, we've got a couple of more examples to go before we're done. For this one, researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of group 50 and 84 are recruited as participants. I think you can read the rest of this, and when you're done reading and done answering, you can start up the videotape for the correct answer. Population, that's everybody we're talking about, is men aged 50 to 84. The sample is the 400 men who participated. Remember, sample's always a subset or a part of the population. The experimental units are the individual men in the study. It's nice to know you're an experimental unit, right? The experimental variable is the oral medication, whether you're being given or not, which type you get, and so on. Treatments are aspirin and a placebo. And the response variable is whether or not the subject had a heart attack. Okay, I'm just going to pause that up there a second in case you want to pause your screen and work on it. And the last slide for today, I would like you to answer all 3 of these, and then I will give you the correct answers when you're done. So start this up when you're done with all 3 of these questions. Okay, first one, a researcher is investigating the effectiveness of treatment for adolescent boys who are taking medication for depression. A group of 30 boys is selected and half received the new treatment. In addition to their medication, the other half continue to take just their medication without any treatment. For this study, identify the population. That is, the adolescent boys taking the meds. All the adolescent boys taking the meds. Identify the sample. That would be the 30 boys selected. Number 2. Define the terms parameter and statistic. Be sure that your definitions of population and sample are included in your definitions. When you write that out, you should get parameters are derived from the entire population. Statistics are derived from the sample. Okay? And last, number 3, statistical methods are classified into 2 major categories, descriptive and inferential. Describe the general purpose for the statistical methods in each category. Descriptive stats summarize data, and inferential stats derive from a small group and apply the conclusion to a bigger group. All right, everybody, you can now, our lesson 2 is over for the time being. Have a fantastic and awesome, wonderful day.